everybody, this is Meghraj and I welcome you to my YouTube channel. Today we are going to solve the next numerical from chapter Light. Dear friends, this numerical is very important in terms of concepts. So dear friends, listen to me very carefully. Let's read the question first. List the new Cartesian sign convention for reflection of light by spherical mirrors. Draw a diagram and apply these conventions for calculating the focal length and nature of a spherical mirror, which forms a 1/3 times magnified virtual image of an object placed 18 centimeter in front of it. So this was the question asked for 5 marks in the board exams. So dear friends, this question is important in terms of concepts as well as in terms of calculations and interpretation. So dear friends, that is the important part here. What? The calculation and the physical interpretation of the calculation. So that is a very vital part of physics. Okay. Whenever you are deriving a derivation, means you are getting a formula for a derivation, through a derivation I mean. So at that time, every step is important. So you should be able to interpret what depends on what. Okay, so that's the main thing. So here also we are going to interpret the calculations finally to find out the nature of mirror as well as the other aspects. Now, first of all, what we will do, we'll go through the new Cartesian sign convention for spherical mirrors. So in spherical mirrors, we have concave mirror and convex mirror. Okay, so these two diagrams are drawn according to the new Cartesian sign convention. Now here, dear friends, this line represents the x-axis, the pole represents the origin, and the dotted line that is drawn above the principal axis and below the principal axis, that is the x-axis here. It is called the y-axis. So here I have shown that if this is the object, okay, so object height will be always in positive. Why? Because y-axis is always positive above the origin, means this part above the pole will be always in positive, whereas the below part, that is everything that is below the pole or the origin, will be counted as negative. Why? Because here comes the negative y-axis. So that's why the image height will be measured in negative, whereas everything to the left of the pole, that is left from the origin, that will be the x dash axis. So that will be measured in negative, whereas everything in the right side of the pole, that is the origin, will be counted in positive. Okay, so that is the new Cartesian sign convention for mirror. So you can observe here clearly that the focal length or focal length, no, not focal length, focus, the point, the focus point, that is this point, is at the left of the pole, whereas in this case the focus is at the right side of the pole. So in this case the focal length measured will be on the x dash axis, whereas in this case the focal length measured will be along the x axis, that is positive x axis, and here negative x axis. So after finding out the focal length through the calculations, we will be interpreting if the focal length comes in positive, then it will be a convex mirror, and if it comes in negative, then it will be a concave mirror. So dear friends, this is the interpretation through the new Cartesian sign convention. Let's see. So first of all, let's jot down whatever is given, magnification is given, that is plus 1/3 times. So dear friends, the magnification is in plus. So what does it mean? We can interpret that the image is forming above the principal axis. That's why the magnification's magnitude is in plus sign. Okay. The next thing is object distance is given. How much? U is equal to minus 18 centimeter. So it may be mirror or a lens, the object distance is always measured in negative. So minus 18. We know that magnification is equal to minus image distance upon object distance, that is image height upon object height. So we know the object distance. So I just kept the value. We know the magnification, that is 1/3 times. So by that we got V, that is image distance, as plus 6 centimeter meter. Now, dear friends, listen to me very carefully. The image is forming on the positive side of x-axis. What can we interpret? The image is forming on the positive side, that is this side of the x-axis. So it means that the image will be forming here or here. Okay. So far we don't know what kind of nature of the mirror is. It's concave or convex. We just now, after finding this, we can say that the image will be forming behind the mirror. Okay, that's the thing. Okay, that's all we can interpret so far. Now, dear friends, we know the value of u, we know the value of v. Now we can find the value of f, that is the focal length, by using the mirror formula. See, the mirror formula. After that, I kept the values, and what I got is f is equal to plus 9 centimeters. So right here, you can interpret that the focus, or the focal length is in positive. What does it mean? It means that the mirror will be convex mirror, because only in convex mirror the focal length comes in positive. Now, dear friends, I'm going to draw the diagram of this. That is the diagram for the question, and I'm going to show you. Okay, let's see. So, dear friends, the pickle is served for you. So many of you may find this diagram a bit cumbersome, but let me make it simple for you. Let's see how to draw this diagram, or how to interpret the diagram, or how to understand how to draw this diagram. Let's see. First of all, only think or look at those rays which are just getting onto the mirror and then getting back from the mirror. That is the incident ray and the reflected rays. Do not look at anything else. Let's start. From point A, this ray is going exactly and hitting the mirror and getting reflected back through this path. Whereas the ray which is below this incident ray, that is another incident ray, this is going and hitting the mirror and coming back through the same path. Okay, so it's not changing the path. The above ray is changing its path after reflection, but the below ray is coming through the same path. Now, dear friends, we are going to deal with the rays which are drawn after the mirror. Now listen to me very carefully, dear friends. See, what do we say actually in reflection? Any incident ray parallel to the principal axis after reflection passes through focus. But in this case, you are seeing this incident ray is parallel to principal axis, but after reflection, it is getting diverted in the same opposite direction, you can see. Okay, so this is the incident ray and this is the reflected ray. But if we go through the path of retraceability of path of light, that is, the rule of retraceability of path of light, that is, if we retrace the reflected ray, okay, if we retrace the reflected ray, then it will exactly pass from the focus. Similarly, in the second ray, this incident ray is getting reflected by the mirror through the same path. So if we retrace this ray beyond the mirror or behind the mirror, it will exactly pass through the center of curvature of the mirror. Okay, are we clear with this? The two rays. Now comes the third ray. The third ray is exactly the normal, that is perpendicular, drawn at the point of reflection, that is at this point. This dotted line is exactly made perpendicular to the surface of the mirror, and it will pass through the center of curvature of the mirror. That's it, guys. Nothing more, nothing less. Okay, so I think I'm clear with the diagram. You'll be able to draw the diagram easily, and by the calculations that we done previously, we know these all things, and I've drawn all these things. That is, the object distance is minus 18 centimeter, the image distance is plus 6 centimeter, and the focal length is plus 9 centimeter. So that's all for today. Thank you very much for watching this video. I'm gonna emphasize only on concepts rather than calculations. Calculations are not so tough, but understanding the question, then interpreting the calculations after the calculations are done. Okay. physical interpretation of calculation. That is also a very important aspect. So thank you very much for watching this video. Subscribe to my channel and hit the bell icon to never miss a video. Thank you very much.